patterns clearly for each function. And so if I hover over this, then you get information about that particular function. You can see the name of the function, so this is just main, and the exclusive time and the inclusive time in that function, and you can see in the source code where it's at, and it will give you that information across all these different nodes. So we've got main, and we've got MPI reduce, and we've got a few other functions. So if you, like I showed you, if you left click on mean, it'll show you the average across everything. If you left click on any of the others, it will show you the exact time that each function took on that particular for that particular process, that particular MPI process. So process 1, so you can see the exact numbers for each given process just by clicking here. So if you right click on that node, then you get a bunch of options here. And so I referred to a few of these. You can, if you have call path enabled, which we didn't on this one, well, I submitted one which we do, but I have to go back and get that. Then you can look at the call graph here. I don't think this will show anything, because there's nothing there. But you can also get, so I'm right clicking on the name of the node. So these are all, again, all the statistics that these will show you are specific for that particular node that you're looking at. If you want the mean statistics, then you right click on mean. So you can check out the mean statistics table. And this is kind of nice because you can sort things, all these different functions on the number of calls and the exclusive time. And when you have call path enabled, then it opens up a tree that branches out. And I can demonstrate that. But there's a lot of information that you can get to from these, from right-clicking on the node level. If you right-click on the function, you can ask it to show you the source code. If you have the source code on your machine, then I think that will work. If it has to know where to find that. And there's various other things that you can look at. This is the same view that you get. This is the histogram. The same view you get if you click on the function. Then it just shows you that function from the one that took the most time to the one that took the least time. And there's various options that you can play with here. You can show the values as a percentage of the total time. And you can select what units you're looking at. This is in seconds. You can go to microseconds. You can also change the metric if you want to look at inclusive time rather than exclusive time. We're in main, so of course everything took exactly the same amount of time, pretty much, as far as inclusive time. You can also look at the number of calls. Again, we're in main here, so that's not. So anyway, so you can, and then you don't have to sort on the metric that you're showing. You can sort it on the exclusive time, and so you can manipulate this view in various ways. So it's just interesting to sort of play with some of these options, and sometimes those are quite useful. So I'm going to grab. Oh, here, before we leave this one. Stepping through, if we kind of go through the process we described in the talk, after you instrument a program for the first time with tau, then you want to make sure you get rid of the overhead, those small routines, and so you go to the File tab here and click Create Selective Instrumentation File. And so you can see there's a number of tiny routines that tau would exclude to get a better, to reduce the overhead. So you just click on that and then you click Save. And it will save this in the directory that you're working in. Now actually, It's best to do that from the machine that you're running on, so that it just saves the file there directly. So you can do that if you've got X Windows running. By just invoking paraprof. In the same directory where you have all these profile files. So by default, paraprof will read those, the profile. Okay, so now we have the same view, except I'm running it just remotely from that directory. And this is this X Windows system, sometimes the arrow doesn't quite align with where you're actually at. But so you just click on this Create Selective Instrumentation file. And there's the same functions that we saw before. Actually, the MPI functions are accessed through a library. It's just the MPI is a library, right? You're not instrumenting that code directly. And so, so it uses something more akin to sampling to intercept the MPI libraries. So this is kind of a when you see MPI appear in there, you're not actually going to be excluding the measurement of the these MPI calls. It can't. You're just excluding what you instrument at compile time. So this is sort of a bug that it shows this. It's something that I think they're going to get rid of in future releases. Also, if you have call path enabled, sometimes you'll see two functions. One is just the plain function here, and the other is the function with all its call path information. The one with all the call path information does nothing. All that this understands is just the name of the routine that you're going to exclude. So that's also excess information that's not actually used. So, but in any case, you click Save here, and it will save it on the remote system. So now, if we go back, we have this select.tau file. And so now I can show you what I was trying to describe. So this is the format of these files. So there's all the functions that we want to exclude. And then there's just delimiters. And these are defined in the tau documentation. But it's pretty straightforward. This is the list of functions to exclude. As I mentioned before, if you just change this to include, then these will be the only functions that are instrumented when you recompile with this selective instrumentation file. But what we want to do here is we want to just get rid of those because they're creating a lot of overhead. So so that's how that works. You just you look at either that cheat sheet or the tau documentation to see what the names of the delimiters are, and then you can specify functions to either include or exclude, and do a number of other things also, like with the phase profiling that I showed you. There's it would be like I think you have an example actually of that in those unres examples, and I think also in LAMPs. There's a selective, select MD phase. So for that, there's the delimiters begin instrument section, and then you use this static phase command, give it the name of a phase, and then tell it which file you want to look at and between what lines. This is for unres. The reason why there's 3 lines is because of this. It uses this master worker paradigm, and so actually the process 0, the master process, is the only one that goes through the loop in this file, and the workers are infinite loop waiting for instructions from the master, and so you have to go to different points in the code to grab all the work that's done within the MD loop. So anyway, that's how that is done. So you can.
UCLA has a question.
Sure.
I'm trying to build my own project, and I found another file that's only readable by the owner. It's the tau.h file.
And what machine is that on?
Ranger.
On Ranger.
It's in the tau 219-.1/include directory.
Okay, I'll work on making sure that that's in place. Okay, so we just saw how to do the so to create that selective instrumentation file. So I'm going to just double check here. Okay, so this tau.h, I think this should be the right one. Should be all good to go. Let me know if that's not. Okay, so let's look at the, if we go back to this example, then we had this profile run with the call path. So this one, we had these tau call path variables set when we ran, and so so now we're going to do the same thing as we did before. We're going to run paraprof. We're going to tell it to pack it up, and we're going to create this .ppk file. And I'm going to go ahead and copy that. Okay, so now that's also on that same web page. Okay, so we can open that up. And now, if you click on the name of this over here, one of the nodes or the mean, if you left click on that, so now we've got all of the information on the path to all of these function calls. So again, like I mentioned before, you'll see multiple of these. One is the total of all the calls, and then all the rest will be the specific call. And you can see where in the code it was called from, and a bunch of information like that. And also, I just want to show you that if you right-click on, say, node 0, or let's just do the mean, then you get, so here's the call graph. So that's what this looks like. So it shows you hotspots in the code with the coloring, and so you can see where the time was spent, and you can, if you click on one of these, you can stretch these things out, but if you scroll over it, it'll give you the information about the different functions that you're looking at. So you can see the relationship